Hello, and welcome to session number 23 of FileMaker Group Therapy for Citizen Developers. My name is Tim Jones. In today's session, we're going to apply what we learned about the ExecuteSQL function in our previous session to dashboards and charts. In the process, we will discuss performance concerns with unstored calculations. We'll look at the SQL functions of count and sum and month. We'll also be using the SQL clauses of join, group by, order by, and fetch first n rows. We'll infuse dynamic parameters and comparison operators into our calculations. And we'll also get the opportunity to explore the new while function to loop within a calculation. The while function was added in FileMaker version 18, so it's still, relatively speaking, a very new function in the calculation language. All right, let's dive right in. I've got my animal care database open that we've been building through these sessions. And here we have the start of a dashboard style layout that we will use to present some grand summarizations to our users upon them opening the database. I'll show you in layout mode that all I've done is added some text objects to the layout with merge fields in them, right? A field called appointments today count, another one appointments future count, and so on. I made them into separate text objects so that number formatting could be applied differently to those that should look like money versus those that should not. And then also let me show you those fields themselves in the Manage Database dialog box. Those 8 fields that are on the dashboard are these first 8 fields here. You'll notice that I did not create these new fields as calculation fields, but rather as number or text fields. If I had created them as calculation fields, they would have to be unstored calculations. That is, calculations whose results are not stored permanently in the field, but rather are calculated at the moment when needed to display or print. The problem is unstored calculations take time to evaluate. And if we put too many unstored calculations on the same layout, it can slow down that layout. Before I knew better, I had made layouts in the past that took 30 to 40 seconds to fully render, and most users just do not have the patience for that. By the way, here's how you set a calculation to be an unstored calculation. I'll create a field called example that's of the type calculation, click create. And it's here in the storage options dialog where we can declare that this calculation field should not store its results, but rather should recalculate them on demand when needed to be displayed on the screen or printed. So that's what we mean when we talk about an unstored calculation. I'll go ahead and cancel out of those. We don't need that new field. Now, if you're wondering why we would have to set our formulas as unstored calculations, well, hold that thought. We'll come back to that in a moment when we write our first formulas. The approach we will take instead is to write a script that performs the calculations and puts the results into these dashboard fields, but only if the user clicks a button. You see, we do not want users to have to wait for fresh results on these summarizations unless they choose to. All right, so let's get that script started. In the script workspace, I'll duplicate our script template. And we'll call this new script refresh dashboard. We'll add in our comments just to practice good habits. This script will be called by a button on the home layout or home layouts, if we have one for desktop, one for iPad, one for iPhone, one for web, and it will not expect any incoming parameters. Most of our scripts call this little script startup script that sets error capture on, allow user abort off, and closes popovers. But this script, the refresh dashboard script, will not need to call that one. So I'm going to delete that statement, and we'll just get right into our first script that's going to set the value of this field here, this appointments today count field. The script step to set the value of a field is called set field. I'll type SF, set field is highlighted, hit return, hit the space bar to trigger that blue gear icon, and then the space bar again to trigger the specify button, and we'll find the field we'd like to set. Appointments today, count. For the calculated result, we're going to use an ExecuteSQL function to go and count the number of visits that are coming up on the current date. Now, ExecuteSQL comes in by default looking like that, but, and I'm going to hide this so we can get more room, but I have it written out with line breaks the way I want it and indentation, and I'm just going to copy that skeleton or empty shell of an ExecuteSQL function that I've got stored over in this text document. And I would suggest that as a good habit to get into. Make empty skeletons of the functions that you use frequently and store them in a text file and keep them handy so that you don't spend time cleaning up the line breaks and indentation. Remember, the ExecuteSQL function's 3 arguments are your SQL query is the first one. The second one is your field separators. The third one is your row or record separator. And optionally, there's a 4th argument where you can put in some dynamic parameters. Our SQL query here is going to say select. That's the only statement in SQL that our ExecuteSQL function supports. So they all start with select. And then we're trying to count what? Well, count all fields. The asterisk means all fields. We could specify a specific field like the ID field, the primary key field or something, but the asterisk is perfectly sufficient because we're really just trying to get a count of the number of rows. Rows from where? Well, from our visit table. And there's a table called visit. Those of you who have been regular attendees know the table structure of this animal care clinic database. So we're going to say select and count the number of rows from the visit table where date equals, and then we want today. So I'm just going to put a question mark there. Now, we learned in our last session that the word date, even though I have that as a field name here in the visit table, the word date is a SQL keyword. So I have to wrap it in quotes, don't I? Yes. To say, hey, treat that as the literal word date, not as the function name date in SQL. But the quotes would cause problems because this ending quote would be considered the termination of this opening quote right here. That would be a quoted section. This would be just kind of lying in limbo, and then this would be a quoted section. So I have to escape those quotes to say, don't treat those as programmatic quotes in the statement, rather escape them to treat them as literal quote characters that I want included in that statement. Next, let's handle that question mark. There is SQL code for returning current date, but let's pretend that we don't know that SQL code. We certainly know how to get today's date in FileMaker. And so we can use the question mark here as a placeholder for a dynamic parameter that's that 4th argument. If we're going to use the 4th argument, we have to put a semicolon after the 3rd argument to say, let us use that 4th argument. And of course, get current date is the way in FileMaker that we ask for today's date. Now, before I click OK on this equation, on this expression, let's go back to our discussion of unstored calculations. I mentioned that unstored calculations can take time to resolve. Now, why would this formula's result have to be unstored if we had decided to make it into a calculation field instead of doing it the way we're doing it, where we have a script that will perform the calculation and fill a number field with the result? Why would it have to be unstored? Well, it's because of what triggers a formula to update its result. You see, when you first create a calculation field, you write the formula in the Manage Database dialog box, you click OK, and FileMaker immediately starts evaluating that formula and produces a result for each record. But after that, what causes the result of that formula to update itself in any given record? In other words, what triggers the refresh of a formula result? Well, unlike Excel, formulas in FileMaker do not update their results just because we close and reopen the database. Okay, if that doesn't work, what does? I'll tell you. A change in the value of a field that is referred to in the formula will trigger the formula to update its result. Let me say that again. A change in the value of a field that is referred to in the formula will trigger the formula to update its result. Well, does this formula refer to any fields? No, it doesn't. Get current date is not a field, it's a function. Well, but what about the date field inside our select statement? That's a field, isn't it? It's not one that FileMaker recognizes. You see, this whole SQL query is one quoted string. It's a big ball of text. And FileMaker cannot dig through that text and recognize FileMaker field names. There is nothing in this formula that would trigger an update to its result. It would remain stuck at the result it returned on the day we defined the field. Therefore, we would have to make it an unstored calculation to force it to update whenever displayed. And unstored calculations take time to render. You put too many of them on the same layout, and that layout may take a long time to render. That's why we're using number and text fields on our dashboard and setting the results with a script triggered by the user. The user gets to decide when they're willing to wait for fresh dashboard results. We'll click OK and save the script. Then let me add a button to this layout that we can use to trigger the script. We'll label it refresh and make it perform the action of performing our script, the refresh dashboard script, like so. Exit out of layout mode, save the changes. I'll click the refresh button, but we don't see a result here because there are no records in this table. This layout is based on the Z utility table. We don't have any records in here. Now, fields defined with global storage will show values even with no records present, but regular fields like these require a record. Let me create a new record and then run the script again. Click refresh, and we see we've got 2 appointments coming up today in our animal care clinic. Fantastic. Next, let's skip down to invoices due and count the number of visits that are not fully paid. So I'll go back into the script window, hit return to make a new line, type SF, hit return, hit the space bar again, and the field we're trying to fill now is invoices due count. For the calculated result there, I'll paste in my ExecuteSQL skeleton, and we'll say select and count all fields from the visit table again, where, and then in that visit table, there's a field called total due. It's that one right there. Total due is a calculation field, as you can tell by this icon, that takes total price, how much the visit cost, minus the amount that the customer has already paid, if any, to result in total due or balance due on that visit. And so that's the field that we're going to put in here. If I double click on the field, it will type it in for me, but I'll have to remember to get rid of the table prefix because that's not SQL compatible text. That is FileMaker syntax. SQL syntax doesn't use that same way of expressing a table name or a field name. And we'll say, find and count all the visit records where the total due field contains a value in it that's greater than 0. In other words, where they still owe money. Simple enough. In terms of these operators in SQL, we've got greater than, we've got less than, we've got greater than or equal to, like that, less than or equal to, like that, even not equal to, like that, with the greater than and less than symbols placed back to back. So we wanted just greater than 0, and we'll say OK, and save the script, and refresh, and we see that there are 4 invoices that are still have balances due. This next one will sum up the amount of money due from those invoices. It'll be so similar that I'll just duplicate this script step and then change the field, of course, that it's filling to the invoices due sum field, and then change the calculation a little bit. Instead of counting the number of overdue invoices, we'll sum the field called total due, that same field that we were just talking about. So we'll sum the values in the total due field where total due is greater than 0. We'll say OK, save the script, rerun the script, and we see that we are still owed $416 on those outstanding invoices. Nice. Next, we want to count the number of animals who have birthdays in the current month. Okay. So for that, we'll make a new line in our script, type SF, spacebar, and it's the birthdays count field that we're setting. For the calculated result, I'll paste in my ExecuteSQL skeleton, and we'll say select and count all fields from, this time from the animal table, right? From the animal table, which let me show you that just as a reminder. Select and count the number of rows from the animal table where the month of their date of birth. So we've got a date of birth field for each animal. And there's a month function in SQL that works exactly like the month function in FileMaker. Okay, where month of the date of birth field, like that, this month function in SQL will return the month number out of a date field or a date value. And we'll say where month number of the date of birth is equal to, and then I'm going to use a question mark again to hold the place of a dynamic parameter. Again, in SQL, there is a way to figure out the current date's month number, but let's pretend that we don't know the SQL code to write that. And so we'll do it in FileMaker because it's easier. We know that one. We'll add the semicolon to the third parameter so that we can use that optional fourth parameter. And we'll just use our FileMaker month function and get current date. So we're in the month of October right now. And so the date, October 13, 2021, the month of that would be a 10. So we're basically saying, find the animals and count them where they have a birth month of 10. We'll say OK there. And save and refresh. And we see that there are 2 animals with birthdays this month. Now let's circle back to the appointments and count the number of appointments scheduled for the next 7 days. Okay. Add a new line, SF, return, spacebar, and this will be appointments future count. How many appointments do we have coming up in the next 7 days? Okay, I'll paste in the ExecuteSQL skeleton, and we'll select and count all fields from visit again, since we're talking about visits or appointments. And we're looking for the range of dates between today and 7 days from now. So we'll say where the date field, the date of the visit, and that has to be quoted and the quotes have to be escaped. And here's a new operator in SQL. It's the between this and this comparison operator in SQL. A wonderful little way to find ranges. In FileMaker, of course, we'd use 3 dots, but SQL says between this and that. Now, the question marks mean that I'm going to use some dynamic operators indeed. So I'll type the semicolon there. And we want between today, so get current date, and then a semicolon, because I'm going to use a second dynamic parameter, today plus 7, a week from today. The first question mark in the select statement in the SQL query will be replaced with the first fourth argument, the first dynamic parameter. The second question mark will be replaced with the second dynamic parameter, and so on. This will work, okay? But it actually kind of bothers me to call that get current date function twice. It seems redundant. We could use a function variable to store the current date instead. Let's wrap the let function around this ExecuteSQL function so we can define that variable. We'll say let, and then it's parenthesis, and then it's got square brackets for the variable declaration section of the let function. And then we'll indent each of these. So we keep our nice indenting for nested functions. And then the let function needs its closing right parenthesis there. Okay, so now we've just wrapped the let function around ExecuteSQL. That will allow us to say, let there exist a variable called today that's equal to, and we're going to grab this get current date, and I'll just cut it and type today in its place and paste the get current date up there like so. And then likewise, we'll say today plus 7, right? Now we don't have to call the get current date function twice. We can store the current date in a variable called today and just refer to that variable. Now, while we're at it though, we'll define a variable called range, because this 7 here, being so down deep in the code, it's going to be challenging if we ever decide to change the upcoming appointments logic to the next 3 days or the next 14 days or whatever we might want to do. Let's surface that 7 up higher in the code by creating a variable. We'll call it range, for example, and set it to be equal to the 7 like so. Then we can replace this 7 with a call to that variable like that. That way, in the future, when you decide to change the outlook of this upcoming appointments parameter, we see it right here, very easily found and changed. And then make sure that every time you had referred to that constant value, you now change your code to refer to the variable name. All right, we'll save that script and refresh, and it tells us we've got 9 visits upcoming. Again, the first way would have worked fine, but we get the same result here just with better looking code. Next, we'll calculate revenue received year to date. Here, of course, because we're dealing with year to date or current date, we'll use the get current date function to find out today's date, but we'll also need to generate the date January 1st of the current year. The definition of year to date is starting from January 1 to the current date. That means more variables. So this time we'll go ahead and start with the let function. I'll make my new line, set field, spacebar, revenue year to date, and come over here. And then I'm going to go back over to my text edit document and grab a copy of the let function with the ExecuteSQL function already nested inside, and we'll paste that. There we go. All right, let's say let there exist a variable called today that's equal to get current date and a semicolon. And in the same manner, let there exist a variable called maybe start of this year that's equal to the date that we get when we call the date function and we pass into it month number 1. All right, we're looking for the first day of the current year. So the first day of the year is always January, day number 1. And then of what year? Well, we're going to run FileMaker's year function on today, like so. And that will result in a date that is January 1st of whatever year today's date is in. Now we're ready to write our SQL statement. Select and sum that total paid field. Let me show you that field. It's in the visit table. Okay, total paid here is the monies received for a visit, right? The customer comes in, we treat their animal and they pay us. So total paid is the number of dollars paid for a visit, and we're going to sum all of those total paid values found in the visit table from visit, where the date of the visit was between this and this. And for the dynamic arguments, to replace the question marks, we'll come down here, use our fourth argument, and we'll start at the beginning of the year. So start of this year, and then a semicolon, and then we'll end the range with today. So sum all the amounts received in the visit table for visits between January 1st of this year and today. All right, we'll say okay there, save our script, refresh, and we see that year to date we've brought in $21,519. Cool. Next, we want to find our MVPs, the most visits by a pet. Here we're going to list the names of the animals who have visited our clinic the most times. Now, if we were doing this as a FileMaker layout, we'd build a sub-summary layout. I've got a kind of a picture diagramming what this layout would look like in FileMaker. We'd build a sub-summary layout with no body part, just a sub-summary part, base it on the visit table, include the animal name field and a summary count field here. We would sort the records by animal name, descending, with the option to reorder based on that summary count field. So in sum, we end up grouping the visit records by animal, and you can see the resulting report in the background here. We end up grouping the visit records by animal and then sorting that list by their number of visits in a descending fashion. Okay, so these are visit records, but we're counting the number of visits per animal and then sorting the resulting list in a descending order by that count. Now, here's how to do that in SQL. I'm going to do this in the data viewer so that I can introduce each clause in turn and show you the results as we go, because it's a little involved. Here in the data viewer, we'll be able to write an expression that we see the results instantly. I'll grab a fresh copy of my ExecuteSQL skeleton, paste that in, and here we go. Select, as always, the name field, because we want to see the animal's names, comma, and then the other column that we want to fetch is the count of all visit records, right? So count from our visit table. Immediately, the error shown in the result pane says, wait a minute, that column called name, that's not in the visit table. Well, right. And so we're going to have to set up the join, set up the relationship between the visit records and the animal records. As I show you the visit table again, we see that there's a foreign key field here that indicates what animal that visit was for. So a foreign key there. And then likewise, of course, there's a primary key in the animal table. Now, there's a relationship on the relationship graph between visit and animal, but ExecuteSQL does not use the relationships on the relationship graph. That's the most curious thing about ExecuteSQL. It uses table occurrence names, of course. This has to be a table occurrence name on the graph, but it ignores the relationships between table occurrences. And we have to, or we get to, define those relationships here. And that's where we use join clauses in our ExecuteSQL statement. So we're going to join in the animal table on the ID animal field, that's that foreign key field, having a value that equals the value in the ID field of the animal table. Okay. Note that I did not have to prefix the ID animal field with its table name because there's no confusion. The ID animal field is only found in the visit table. There's not also one in the animal table, whereas there is a field called ID in both the animal table that we're joining in and the visit table. That's why I had to include this table name prefix here to make it clear which ID field I was talking about. All right, the resulting error now says, hey, wait a minute, all non-aggregated column references in the select list, non-aggregated. Well, the count function here is an aggregate function, right? We're aggregating the results from this select, from this fetch. The name field is a non-aggregated column. It's just a regular old field. All non-aggregated column references must be in the group by clause. In other words, you can't perform summarizations and still have regular fields sitting there in the select field list. So we use the group by clause in SQL, group by like that, to group the results, group the found visit records by, and I referred to the animal name field, and immediately we start getting our results. Nice, right? We get animal names followed by how many times they've visited. By default, your SQL query results are going to come back sorted by the same field that you grouped by, but we didn't want them sorted by animal name alphabetically from A to Z. We wanted them sorted by or ordered by. That's the clause that we use for sorting in SQL. We'll say order by, oops, too many spaces. There, order by, and we're trying to order them by the number of visits, by the count of visits, right? Sadly, though, you can't use an aggregate function in your order by clause. It doesn't work. We still get the results alphabetized by animal name. Fortunately, SQL provides a way to give a name called an alias to a table or a field or even to an aggregate function like our count function here that appears in the select list. We use the keyword as like this immediately following that aggregate function, and then we just make up some name that we want to use as the field name for that column. I'll call it num visits, as in number of visits. And now that it has kind of a field name, we can use that num visits name down here in our order by clause. We can use that alias name, order by num visits, boom, immediately the results snap into place, sorted by or ordered by the count of visits. But we get the low ones first and the high ones last. We wanted them other way around, high down to low. And so we'll just add in descending. DESC is the abbreviation for descending in SQL. ASC is the abbreviation for ascending, though you'd probably never need to use it because that's what you get by default. So DESC says, no, reverse the sort order. And we've got basically what we wanted, although we really only wanted the first 3 records or so, not the whole set. We've only got room for about 3 animals' names here on our dashboard. And so here, we're going to use the fetch first n number of rows, okay? Fetch first, and then you could put any number here, 1, 2, we're going to go with a 3 because we want 3 rows, and then the word row or rows, depending on if you put a 1 or a number higher than 1. Then you can either use the word only or the phrase with ties. The difference is if you put only, then you're only going to get the first 3 rows, even if there was a tie for first place or second place or third place. Okay. Whereas if we put with ties, let's say that there was a tie for first place. There was another animal that had 78 visits. Then with ties specified here, we'd get all 4 records returned, not just the first 3. Now, please note that there are various dialects of the SQL language. For example, in place of fetch first n rows with ties, which FileMaker understands, some database systems would need you to write top 3. Others expect limit 3, and still others would want where row num is less than or equal to 3. For more information on the exact dialect of SQL that FileMaker understands, consult the Claris SQL reference at this location on the web. Okay. Finally, on the dashboard, we want to present these animal names and visit count numbers on one line, not on 3 separate lines. So let's play with the field separator and row separators here. Remember from our last session that we learned when we leave these blank by just putting quote, quote with nothing in between, we get the default values of commas separating the fields. We see that here in the result, and carriage returns separating the rows or records. But if we put a space as the field separator, look how the commas go away. If we put, likewise, as the row separator, a comma and a space, those two characters replace the carriage return, and we end up getting the results all on one line. That's exactly how we want it to look. So I'll copy all of that and paste it into our script. Okay, we'll do our set field, return, spacebar, spacebar. This is the most visits by a pet, the MVPs, and paste. Okay, save the script, refresh the dashboard. Look at that. We get those 3 animals who have visited the most times. Nice. Next, we'll do the opposite and list the healthiest pets. That is, the pets with the fewest visits. But this time, we'll limit it to just the past year. Okay, so at line 12, we'll add a set field saying we want to set the field of the healthy pets names, set the value of that field. And once again, we're going to need to use the let function. So let me grab a copy of this skeleton. And let's say, let there exist a variable called today that's equal to get current date, like so. And then in our SQL query, we'll say select the animal name, comma, and the count of all fields from the visit table where, oh, sorry, got to do our join first, right? Since the name field doesn't live in the visit table, we've got to join in the animal table. So join animal on where the foreign key field in the visit table has a value that matches the primary key field in the animal table. There's our join, our relationship. Now we can do the where the date of the visit is between this and this. And before I forget, I'll go ahead and add in those dynamic parameters, put in the semicolon after the third parameter. And we're looking for the past year. So we'll say today, which is our variable defined up at the top there, minus 365, and then a semicolon, and just today alone. So in other words, from last year today to current today. Now we wanted to group the number of visits by name, animal name, group by name, and we wanted to order the results, order by the number of visits. Oh, that reminds me, we've got to add our alias for this count function, this aggregate function. If we want to be able to refer to it as though it were just a regular old field or column, we say as, and then make up some alias for it. That way we can order by that column, that field, order by num visits. We don't have to put ascending, but I'll put it there just so that you can see that that's the abbreviation in SQL for ascending. And let's say that we only wanted to fetch the first 2 rows, and we'll go ahead and let ties be included as well. I don't want to forget to change our field separators to spaces and our row separators to comma space. That'll cause the results to appear all on one line. And then we'll say okay, and save, and refresh. And there we go. All right, we got in a sense, a 3-way tie for first place. But obviously the next higher number must have been something larger than 3. All right, so we've finished all our dashboard data fields. Now we want to add a chart to the dashboard that shows the sum total of revenues received per month for the past 6 months. Now a chart needs 2 sets of data like this. One, labels, and then secondly, 1 or more series of data. Okay, here could go on if we had more series of data that we wanted to plot with the same number of items in each set. 6 items in the month labels, 6 items in the data values. Same number of items in each set. I'll go ahead and draw a chart on the layout. And we learned about charting in webinar number 21, and we learned that one of the 3 sources of data acceptable to a chart is carriage return delimited data from the current record. So if we can put together a string of delimited month labels and also the total revenues received per month, then we can provision this chart. Of course, we're going to write formulas to produce those results. And since this logic might be useful elsewhere, let's write it as a custom function to make it easier to import into other database solutions later on. We'll create a new custom function. I'll call it revenue monthly. Custom functions, like the built-in functions, can take in parameters. And we're going to use 3 parameters. The start date, that is, when do we want to start the plotting of the revenues? The number of months that we want to see, we'll call it period. And then lastly, type, that'll allow us to toggle back and forth between whether this function is going to return the labels or the data. Okay. Now for the formula, let me grab a shell skeleton copy of our while function. Okay. Now the while function, being new, this may be the first some of you have seen it. Let me bring it out in its native state. It looks like that. Here I've got it broken down with line breaks and indentation, though, looking like that, with all of the same arguments, same pieces. First, we get to initialize 1 or more variables. The purpose of the while function is to allow us to loop across some logic X number of times, oftentimes with the desire of concatenating or stringing together a series of results into a concatenated string, which is exactly what we want. Remember the goal, we're trying to produce something like this, a series of month names with carriage returns between them, and also this, later on, a series of values, again, with carriage returns between them. The first variable that we're going to declare here is our counter variable. There needs to be some way of counting how many iterations we've gone through the loop so that we can set a maximum. Okay. Now, you need to know that one of the pieces of logic that we'll employ is where we increment the counter after each performance through the loop, setting the counter variable to be equal to its old value plus 1, like so. Okay, so keep that in mind. We're going to start the counter at 0 in this case, and then we're going to increment it each time through the loop by 1, so it grows by 1. There are a couple of other variables, though, that I want to declare up here in this top section. Declaring them in this top section rather than in the logic section down below makes them so that they're going to live throughout the entire duration of the while function. Whereas variables that you declare only down here in the logic section, they restart their lives every iteration through the loop. So let's say that there's going to be a result, and we'll just set it to blank for now, quote, quote. And then let's also figure out what month number the user had asked us to start in. We'll use the month function, and we'll tell it to find the month number of the starting date that the user sent in, that they passed in when they called this function. The next argument of the while function is the condition under which the loop should be performed. And we want to continue to perform this loop so long as the counter variable contains a value in it that's less than the period that they passed in here. Okay, so if we ask for 6 periods or 4 periods, however many months back we want to look, that's going to be passed in here. That will dictate how many times we perform the loop. Then we come into the logic section. This is where we do all of the thinking part of the formula. Let's create a variable. Since we're going to try to track revenues by month, let's create a variable called first day of this month that's equal to the date that we get when we call the date function. And we're going to pass in that month num variable that we just defined up above, right? Month num here. We grab the month number of the starting date. And then we're going to subtract from it whatever the value of the counter is through this iteration of the loop. I'll talk in more detail about that in a second. And then the first day of the month, of course, is always the day number 1. And then the year of the month is going to be the year function of our start date variable, like so. And then we'll close off the date function like so. All right. Now let's talk just briefly about what this minus counter is doing. So the month number variable, let's say we pass in today's date. We're in October, so this would be a 10, right? The counter variable is worth 0. 10 minus 0 is 10. Therefore, the first day of this month would be 10/1/2021, October 1st, 2021. That's the first time through the loop. The second time through the loop, we will have iterated incremented our counter variable by 1. So now counter is equal to 1. Okay, 10 minus 1 is 9. Now we're getting September 1st, 2021. The next time through the loop, the counter would be equal to 2. 10 minus 2 is 8. That's August. So we're slowly backing our way back through the previous months, giving us October, then September, then August, and so on, as far back as however many periods were stated, because that's how many times we're going to go through the loop. We also need to figure out what's the first day of the next month. So I've just copied and pasted that line, and we'll go like that, first day of next month, and we'll simply add a 1 to the month value of that date, right? So if this was 10 and this was 0, we'd be dealing with October here. 10 minus 0 is 10 plus 1 is 11. We'd get November 1st, 2021, which is indeed the first day of the next month. That's how we're going to be able to stipulate the month range of our revenues. Okay, lastly, we'll create a function, a variable called result, or we'll set it to be equal to, I should say, because we created it up above. Now we'll give it a value, and we're going to use the case function here. And in the case function, we'll say, hey, in the case that the type variable is equal to the word labels, then give us this result. Return the month name of that first day of this month date. First day of this month, which is that variable that we saw up above right there. Okay, we want the month name from it. So October, if the date is October 1, 2021, the month name, of course, is October. And then after that, we want to, I'll use the word prepend. We want to put that month name before anything else that was in that result variable with a paragraph mark or a carriage return between them. So that bit right there says, hey, give us the month name, and then string that in front of a paragraph mark and then whatever was in the result variable prior to this. Second time through the loop, we get September. And so it puts September, paragraph, and then result, which was October. Third time through the loop gives us August. So we get August, paragraph mark, September, paragraph mark, October, and so on. We just keep adding the month names prior to the existing results to build up that list as we see here. And then, of course, we're going to return the result, and it's no coincidence that I decided to use a variable called result, because that's what we're going to pass back as the result of this function. There. So we're saying, okay, set the result to be equal to all of that concatenated stuff, and then finally pass that result back as the end result of this formula. I don't think I made any typos, so that good. We cleared that, okay. And let me go into the script, and we'll add a new set field statement that sets the value of that revenue monthly labels field to be equal to, and we'll call our custom function revenue monthly. We'll say, hey, let's start with today's date. So get current date. And let's look back for a period of 6 months. And let's have this one return the monthly labels. Sorry, labels there. Okay. While we're here, let's go ahead and tackle the other one that's going to pass back the data. So I'll duplicate that script step. And point it to a different field, the revenue monthly data field, and we'll simply say this one needs to pass back the data. Now I know we haven't written our custom function yet to handle that, but we'll get there. That'll be the other part of our case statement. Save the script, and let me throw a copy of those two fields out onto the layout just so we can see if we're getting good results. There, and we'll align them on top alignment like so. Okay. So if I run the script, this field should fill with the last 6 month names. We got it. Fantastic. Now we'll go into our custom function and we'll tackle the other logic, the one that's going to come back with our monthly revenues. So we already said in the case that the type argument was supplied with labels, let's precede that with, in the case that the type was given the value of data, then we want to return this, and we'll bring in our ExecuteSQL function. Let me grab a fresh copy of the skeleton. There. And paste, and I've got some indentation to add. Okay, good. And we'll say select and sum the total paid field from the visit table. Nothing new there so far. Where the date of the visit, oops, missed my quote. There, where the date of the visit is greater than or equal to, and we want the first day of the current month. So I'm going to put a question mark there, and then it will come down here. We'll grab this variable and we'll use it as our first dynamic parameter, like so. Okay, first day of this month. So where the date is greater than or equal to the first day of this month, and I'm not using between here because I want to go only through the last day of the current month. And so we can do that by saying is less than the first day of next month. It's much easier to determine the first day of the next month than it is the last day of the current month, because there are differing numbers of days per month in our crazy calendar system. Now you can't just say and is less than. You have to restate the field name saying and the date field is less than, and then we'll use first day of next. Oh, actually, sorry, I'm going to do question mark there. Is less than question mark there. We can't use a FileMaker variable in the SQL statement. It wouldn't know what in the world it is. So that was a mistake on my part. Sorry about that. We'll say there. So select and sum all the total paid values from visit where the date of the visit was greater than or equal to the first day of this month, and the date of the visit was less than, but not less than or equal to, the first day of next month. Otherwise, in the case that the type argument is labels, then provide the month names, all being concatenated to their prior results. All right, let's see if I made any typos. I forgot something. Let's see what I forgot. Yes, the closing semicolon after that argument right there, because this is an argument of the case function. Here's the first argument, the first condition, and then value if that condition is true. Then the next condition, and then value if that condition is true. And that last one is the only one that doesn't need the semicolon. All right, we'll say okay and okay. And let me rerun the script. And this field should fill with the revenue numbers from those past 6 months. Awesome. So we've got the data. Now we can use those fields to drive our chart. I'll double click on the chart. I know I'm going to want the chart background to be transparent, so I'll take care of that now. And then we'll come in here. Let's make it a line chart. And on the horizontal axis, we'll put those month labels, specify field name of the monthly labels. And for the y-axis for the data, we'll say specify field, and we'll use our monthly data values. We're also going to rotate the x-axis labels about 20 degrees. Otherwise, they'll get a little cramped. This kind of rotates them up on an angle like that. And we can also choose a fun little character for the line markers. All right, we'll say done. I know I had set the chart back onto transparent, but it's still, the chart graphic has a solid fill color as well. So we'll set that to none, and that makes the chart truly transparent. We'll exit and save. And look at that. We've got our chart of the last 6 months of revenue data. Fantastic. So we've seen several examples of the ExecuteSQL function in dashboards and in charts. I know we went long. Thanks for your patience. Any questions about what we've looked at today?